everybody. Welcome to Munro Live Podcast, and I'm here with RJ, and he's going to talk a little bit about, or we're going to talk a little bit about the new dual motor system. So I have a Rivian. It has a quad, and that quad gives me 835 horsepower and about 908 foot-pounds of torque. But I got a chance to drive the new dual, and that's not that far off at 665 horsepower, and then, 829 foot-pounds of torque. So, I mean, I noticed no difference, really, for launch. Like, you know, I like to go fast. I did not take it off-road, but I did take it on one of the worst roads we have around here. So I'm pretty happy. But RJ, I think your team did a really good job.
Yeah. Oh, well, thanks, Ted. Yeah, the exciting thing about this drive unit is we spent a lot of time really focusing on how it's built, the manufacturability. I'm sure we'll spend some time talking about that today. But this is completely vertically integrated. So we build the rotor, the stator, we do the hairpin. Everything is done here in our plant in Normal. And as you said, I mean, the performance is exceptional. So, straight line performance, it's not quite as quick as the quad motor. And we're the quad
0.6 of a second? You think I can notice that? I'm an old man.
Sort of 0.5, 0.4 seconds in a 0 to 60 run is really the difference. But it's a great drive unit. I've been driving one for now about 2 months, and absolutely love it. It's very efficient. NVH is nice, so it's a great setup.
Well, actually, that's one of the questions that I had. What kind of extra range can you expect? Because I only drove it for a little while. What kind of extra range can we see out of the new vehicle?
Yeah, so with the large pack, it's just a DPA rating. It comes out to 352 miles of range. So it's a nice step up from the quad with the large pack, which is a 328 on the EPA cycle. So it's efficient and doesn't really give up a lot in terms of performance. Now, of course, as you know, when you're off-road, the quad motor and the ability to individually control torque at each wheel has a nice set of advantages. Yeah. But for on-road driving, it's a great dynamic platform. Yeah.
Well, my wife drove it as well. Susan, I keep calling it my car, but really it's not. So anyway, Susan said that it was driving a cloud, and it was like driving a cloud. And I don't know what you did with the suspension, but it is different than my quad, than the quad. I will tell you, I drove it over a washboard road. We have a Amazon facility, warehouses, huge amount of truck, and everything's now. I drove it over that. Now, if you go fast, it doesn't, you can't notice much. But when you go slow, it's nasty. And I was very impressed with the way it went. Sue went over it as well. She probably went a little faster than I did, but she said it really worked well. She did not notice anything she didn't like. Everything looks the same to me. I didn't really see anything that was that different, but she definitely noticed the drivability of the car. And maybe that's because it's lighter or something. I'm not sure what, but maybe you can elaborate.
Lighter. Yeah, it's a little lighter. Suspension-wise, it's very similar. Of course, when we put a new drivetrain into the vehicle, we optimize the whole control system to contemplate that drive unit. So the way that everything's tuned is slightly different to deal with less torque and to deal with the fact there's one motor instead of two per axle. Yeah. So that we set it up to be that sort of very comfortable, very smooth riding vehicle. And of course, you still have different drive modes. Not as many as what you'd have in the quad motor, but I agree. I think it's a really nice driving. It's sort of a great base package, if you will, with that kind of performance. It's a great world when the base version of the vehicle is doing 0 to 60 in less than 3.5 seconds.
Yeah, well, to me, I don't know whether one's going to cannibalize the other, but at the end of the day, I'm not budging from mine because I do take it off-road, and I do appreciate the four-wheel drive. But actually, I have one question. that coolant that you're using, it's a dielectric, and because it's splashing around a lot of electrical components.
Yeah.
What is that? Because quite frankly, we tested it. We know it's a dielectric, and it feels kind of slippery, but it's not transmission fluid. What is that stuff?
Yeah, it's a coolant. So essentially, it's an oil-based coolant that we've developed. That's, as you said, dielectric.
You developed it.
We co-developed it with a supplier partner to make sure that it would work for this application. And as you know, on these on lubricants, you spend a lot of time making sure the lubricant fits the application. And so looking at high speeds and extended duration runs and a lot of durability runs, ensuring that the coolant solution and the associated lubrication around any lubrication that results from that works over the long haul. And our durability cycle, I'd love to show this to you. I mean, we're not just running these in dynamometers. We run these in vehicles. We run these submerged in vehicles in mud and water, really hot conditions, really cold conditions. And that was one of the core drivers of this drive unit, is to make sure that it lasts the life of the vehicle, but with very hard and strenuous life throughout its course.
Well, the other thing I noticed too was that you got ceramic balls for the bearings, and do you use that for two reasons? Usually, one is for you get it's less friction, even though it's a ball bearing. It's less friction, and it lasts longer with ceramic. But you also get the ability to ditch EMI. But I noticed that you also have brushes, which I don't have a clue. Why bother? You should be able to ditch that because the ceramic balls don't conduct. I mean,
yeah. Some of this is just in terms of thinking about sort of the life cycle and the duty cycle, and when we think about the bearing strategy and how we set up the bearing strategy, the torque levels is so high that the ceramic ball bearings, as you brought up, they're great from an EMI point of view. They're great from a long-term durability point of view, but we have a lot of sort of redundant, what may seem like redundancy, but that's ultimately because of some of the specifications around life.
Yeah. Well,
and like we'll see that, and I'm sure we'll talk about it some, but the fastening strategy that we have is to ensure that this can operate under these extreme conditions. Yeah. I'm happy to point out some of the areas we see as improvement opportunities. So especially around the power modules and how they're mounted.
Well, let's just jump to this then. This is out of sequence, but why have you got this? I don't get it. So I can see that, I know how this goes together, and I know what it does. Here we've got the basically the inverter. Sorry, I've been flying a lot, and for some reason or other I can't find the holes. But anyways, you've got the inverter here, and then over here we've got the gate driver, and we snapped that together. But I would have just used a piece of tin foil. Is there a reason for this? Is this like for stability or something? Is there a vibration problem?
Yeah, this is an area of the drive unit we whenever we develop a product, you get through all the assumptions and all the iterations. And I was talking to one of our engineers over the weekend that was heavy on this. And you sort of look at it and you say, what are the things we would change? I asked the question as well. So what would we change? And this is an area we see room for optimization. So we'll see that over the course of its life. But also as we look at this being inserted into new programs, I think how we've mounted the gate driver and the power module, really was focused on making sure it was very stable, very robust. Of course, this is an important area. And I think we would agree, some over design in that area. But intentionally so, if you will, given the requirements, but it's a good call out.
It's just it's just one of those things. And being as we're jumping around here a little bit,
I love that you have all the parts.
Oh yeah, I have a lot of parts. Thank you for shipping them over to me. So I don't think I would have been able to do this. But see the black stuff there that you've got coating on the inside. We have no idea why. Nobody else coats the inside of an inverter box. So this is the second thing. Actually, I was going to wait till the end, but shoot, we're here right now. So we looked at that. We couldn't understand why you were.
Yeah, I think what's unique on our drive unit relative to others is if you were to look at, let's say, something out of a traditional vehicle that's designed to spend its life on the road. We have a set of requirements where we want the motor to be capable of running and operating when it's submerged. And then the cooling strategy and the lubrication strategy contemplate that. So some of the coatings and some of the ways that we've achieved sealing are unique with regards to that long life cycle and long duty cycle. And so that top cover, we wanted to create real high stability. The sealing surface you see around the machined edge is there. The fastening strategy speaks to that. And then the inside of it was also to protect against any, to protect for a long life of the part.
So if we look right here at the stator, this is something that I really do like. You got hairpin design, U-shaped hairpin design. So yeah, I've got a weld on this side, but on the other side, all I've got is the braiding, which I'm kind of excited about. This is
pull it over. Yes,
a little bit more. Yeah. So here we've got.
You'll pick that up with one arm. Come on.
Yeah. Right. yeah. Well, next, okay, so why didn't you make this out of aluminum? We could go there, but I don't want. Anyways, at the end of the day, you probably heard me commenting about Lucid's motor. I really, really like that one. But this is superior to the most of, actually, all but one other company when it comes to the hairpin design. So I'm very impressed with this. I think you've done a fantastic job there. And actually, while we're standing here,
part of that too is how we automate that and allow that to happen. The bend radius and how it's inserted, as you pointed out, into the stator and the offset between them.
Yeah.
To make that really easy to do.
Well, here's the other thing that I like. Your resolver here. This one is bigger than the other one, but it's still smaller than anybody else's. And this was a big thing that we noticed when we tore apart the other Rivian. So this is kind of cool as well. You seem to be able to do with your small revolver what other people are struggling with a larger one. So that's another good thing. I think I'm going to just leave this over here from now on. but I will tell you, I am pleased that I'm glad that I got a chance to get this thing and look at it. And there are some really cool ideas. But really and truly, the thing that I'm the most impressed with is the decoupler.
Yeah.
So, and you'll notice it's up here in the front where I was supposed to be. But we're very happy about that. We looked at all the advantages, gives me a neutral, towing. I can tow this now in back of an RV. If I have a big mechanical RV, put it through a car wash. A lot of people that we talk to that are in the, they fix crashes and stuff like that. They like the idea. They will like the idea that they can tow this thing by putting it into neutral or whatever you want to call it, and quite frankly, they just. I mean, nobody else that I know of has got anything quite like this, and I think this is a really good idea. I think this is something that I'd like to have you elaborate on a bit.
Yeah, we spent a lot of time on this. I'm actually glad you bring it up. So on the rear drive unit, we were able to disconnect. And what that does for us is when on the launch configuration, we have that as well, except it's, as you know, it's a manual disconnect. So you go into what we call conserve mode.
Right.
And it disconnects the rear drive axle. Whereas in this, it's dynamic. It's based upon the drive mode you're in. But when you're in all-purpose drive mode, which is like the primary drive mode that's used, the rear drive unit's connecting, disconnecting, depending on torque request, depending on speed. And it's a way for us to get to the efficiency of having only one of the permanent magnet machines, the front drive unit, engaged, and the others not engaged. You're not creating any parasitic loads or losses just from spinning it, which is really powerful, which is great to have. Now, to do that, it means the technical requirements for that disconnect are really high. It has to be able to disconnect very rapidly. It needs to be able to do it very often. So from a durability point of view, on a given drive, you're going to be disconnecting quite often. And it needs to be seamless, where, you and I enjoy the fact that this is happening from a technical point of view, but from a consumer point of view, you don't even want to know it's there.
Yeah.
So a lot of work went into the minimizing the amount of time it takes to connect and disconnect the drive unit, and then making sure that when it reconnects, it's not this sudden sort of hit you in the back kind of feel, like, you don't want it to feel like it's all of a sudden coming in. So the way in which the torque, once it's reconnected, the torque re-engages, was something, our engineers spent a lot of time in the vehicle with laptops tuning. I spent some time doing it as well. And I think we've ended up with something that's really wonderful. We're really happy with it. And of course, you're doing this, you're creating a mechanical connection, but we're using, we have to do that very smoothly as we disconnect as well, so you don't hear any clunk.
Yeah.
So as we went through the development process, late in the process, we were dealing with some corner cases where you could create, under certain conditions, the feeling of it. You could perceive something happening in the back. And we really worked all that out through the software and through the controls.
Well, I normally don't care much for springs. This, though, we talked about it, and I would like to say that, maybe there's some sort of electromechanical movement that we could make, but if we did that, it would clunk. So I guess you can't get rid of springs everywhere. But let me think about one other thing that you seem to be moving away from, and that's carborundum, or silicon carbide. We noticed that you moved from the Danfoss to the Infineon 3-pack. Want to comment on that? Is that I assume it's just from a cost standpoint.
I love how thorough you are. So when we think about the drive, we've talked about this before. One of the big constraints we had in 2022 for production was power modules. And in the case of our existing quad, we have a Danfoss power module that uses either silicon or silicon IGBT or silicon carbide. And what we launched with was we had silicon carbide in the front drive unit and silicon IGBT in the rear. And the supply chain just wasn't robust or large enough to support our ramp. And we felt that acutely with our production volume. So with the bring up of this drive unit, the Enduro drive unit, we really put a lot of effort into making sure the supply chain was robust and such that we could have both silicon carbide with an Infineon power semi, as well as silicon IGBT. And as you point out, we're using a silicon IGBT in the rear drive unit, but the 3-pack, those Infineon that you pointed out, you actually showed it earlier.
Yeah.
Those can either be silicon carbide or silicon, and we have fungibility between the two depending on constraints that exist within the supply chain.
So are you going to put carborundum in the front? That's
exactly right.
Okay,
exactly
so
right.
There's a little bit of a difference between the two
there is
motors.
Slightly different efficiency. Now, one of the things that as we fully build out the portfolio of motors across different vehicle combinations, of course, some combinations and the lower price combinations will just use silicon IGBTs front and rear. So that flexibility is really helpful. So for example, the same drive unit, or I shouldn't say same, a similar version of this drive unit is used in our commercial vans, and the front drive unit in those applications is just using silicon IGBTs and not using silicon carbide, because it's meaningfully cheaper, as you know.
Well, it's meaningfully it does change things a little bit.
It's a little less efficient, but it's a lot cheaper.
Yeah. So, seeing as we're in and around the motor kind of stuff, we obviously didn't chop this thing up. We've got some other stuff going on, and I was out of town. But anyway, they didn't. They didn't cut it in pieces. And taking it apart is a real bugger with the new clamshell that you've got for the rotor. So my guys want to know what's the array look like? Is it a double V still, or have you gone to a single V? Because when we put the green paper on, all we see is a single V. What have you got going on there?
Yeah, that's a good question. I assumed you were going to ask something about that. This is an area that evolved a lot through the development process, and just the level of skew we think of as like that V skew evolved really as we're balancing performance, zero torque or zero speed, like notching feel that you might feel with NVH. And where we've landed, we think is the optimal level of skew that gives us, we think, great NVH performance without really any performance loss and good high torque zero speed operation. And so, as you introduce more and more skew, as you know,
I'm not a fan. Yeah, go ahead.
Yeah, you can start to have a low speed drivability performance issue.
Yeah.
So we sort of balance it just right to get a level of skew that gives us great NVH without having any of that low speed bogging or low speed sort of cogging feel.
Okay, so while we're still hanging around the motor, I've asked the questions about the most of the things, I think, but one of the things that Tesla does that I really like is they use the motor to heat the oil.
Mm-hmm. Mm-hmm.
Is there a PTC heater, or are you using that same system like
we do that as well?
Yeah,
we definitely do the same. We actually do it on our launch configuration as well, where we essentially run the inverter through a process where it's putting off a little extra heat. You also say it's a little less efficient, but it serves as a heater to the system. Yeah, we do that as well.
Okay.
And that's something, it's again, the beauty of something like that is it's software based. So you can, that's something that we can tweak and evolve and improve over time. Seamless to a customer. You wouldn't know that this is happening, but we're constantly looking to improve low temperature performance and the amount of time it takes to heat up the system.
Actually, I've got I guess we ran through everything pretty much that I was kind of really interested in. Is there something else you want to add to the narrative that we've gone through so far?
For us, launching this motor represented, it's sort of emblematic of how we hope to continue to grow as a company, where it balanced manufacturability in a way that had much more of a focus than what went into our launch configuration driving it. So if you look at the 3-in-1 casing, that's a good example. It's all single access for loading the content. Yeah. So you haven't seen the line, Sandy, but I'd love for you to come at some point to see the line here in the plant. But the way that it's built up is it allows for it to be robotically assembled without having to rotate the assembly a lot, which on our Origin drive unit, we're like flipping or reorienting the assembly a lot because there's so many different load planes.
Right.
Whereas in this drive unit, it loads very nicely between all three components, the motor, the gearbox, the inverter. And then, of course, as you showed us on your cart, the lid for the inverter assembly actually carries a lot of content. So it's like the content's in the lid and then it goes on.
Right.
So it was designed to try to minimize the amount of flipping or reorienting that happens through the production process. And of course, doing that to reduce number of fasteners, reduce number of discrete parts. Now the seal plane for all of that still has a number of fasteners, and that's really a resultant of the pretty extreme conditions. Despite the fact that it's not a quad motor, we still anticipate people using this off-road, maybe not as extreme as you, but still getting it wet, getting it dirty, caking it with mud, these kinds of things. So we wanted that seal plane was still very robust.
Yeah. Well, we've we also work in designing products, and we're a very big fan of layered assembly. If I don't know if you've ever gone through our process, but if we go through the process and we code it, anytime you have a change, even if it's 1 or 2 degrees, it doesn't matter. It's still a problem for our software. So it'll come back and give you a big, don't do that. So everything we we design goes together in a vertical sense, and it has to be vertical. I don't want to do upside down or sideways because then I have gravity working against me. But one of the things that we're looking at right now is a fairly large casting that has to be sealed like forever. And I don't think, I really can't see how anybody's going to come back in and, and modify one of these boards or something. Oh, we need to put something else on. Oh, the gate driver has got a bad transformer. That ain't going to happen. So what we've seen with a number of different products that we're working on is we're basically taking the lid and going click, done. So it's a snap fit, no fasteners whatsoever. Nothing is going to get in. So with a labyrinth fit. Anyway, that's one of the things that you might want to think about down the road from a design standpoint. If you know about, or whomever designs it knows about snap fits and how they have to work when you're looking at metal, it makes a big difference.
Yeah.
But what are you thinking about volume and whatnot? How much do you think? How many do you think you're going to be popping out on this one per year?
Well, this underpins every commercial van that we build is using one of these in the front, and then we anticipate our dual motor configuration making up more than half of our R1 production. Importantly, this drive unit family is going through another iteration of design and improvement, but it'll be used in our R2 platform as well. And a lot of the things that I even referred to, if you look at the inverter assembly and some of the opportunities there, which we agree with, those are already being implemented into how we're going to execute. Let's call it Gen 2 of this drive unit to take cost and complexity out. And I think your points on the cover are really interesting. We spent a lot of time talking about some of the durability cycle, but also how can the platform be remanufactured. So we have a remanufacturing line for drive units that are in, let's say, a vehicle that's in a collision. We reprocess them through a facility we have in Kentucky, or motors that are end of life. But I think that can be done with some of the things you've talked about. So, maybe offline, I'd love to bounce some things off you to talk about this. But that's, for us, we're looking at how do we keep taking cost out of this drive unit. The core of it we feel really good about, the rotor stator assembly, the approach to how we've accomplished the hairpin, the windings and the radii on that, the assemblage of that is really, we feel strong. The magnetics, the way they're attached, we feel really good about that. But I think some of the periphery, there's still opportunities to take more cost out.
Well, cost and weight are two things that, with EVs, that's kind of like where those are the two top of the four. Efficiency. Actually, I was going to ask you about this, but we had a discussion about it, and I said, well, maybe not. But one of the things from an efficiency standpoint is the number of Busbars. That's something you really want to have a look at. I think there's something like, there's way more than what we would have expected to see. So that anytime I've got some kind of an efficiency thing that looks like it could either get in the way of power distribution or just extra pieces that I'm going to have to somehow bolt together, it's a good idea to have a look at. And that one that was the one that stuck out the most.
Busbar assembly, there's we've over-designed the busbar assembly a bit. We would agree. And even if you look at how they're encapsulated as well, so it's the part, the encapsulation, the mounting, it sort of ripples. So some some over design there ripples into more than we'd like. So when we think about like the Gen 2 of this, that area, along with how we have the power module mounting strategy, will be the areas that will evolve the most.
I have a question that wasn't on my list, but when we, I didn't get a chance to tear it apart, so I had a team and whatnot, and I was looking at it, and I started thinking, how much more efficient is it if I'm running just the front module and the rear is disengaged? What sort of extra, is there a percentage or something like that you can drop on us?
Yeah, it's it depends on the speeds, but it's call it 5-ish% to have both
5%.
motors. Yeah, to have if you were to for example, when you put it into sport mode, it removes it's constantly connected.
Right.
So the rear drive unit doesn't. So that way, the moment you press it, it's 100% there.
Yeah.
When you're in all-purpose mode, it disconnects. So while you can't really perceive it, when you hit the throttle, the rear motor has to re-engage. And there's
I didn't know that.
yeah, well, it depends on the speed. If you're below 20 miles an hour, it's engaged, but over 20 miles an hour, it disengages.
Yeah.
And of course, that's where you really start to see the efficiency loss when you're at higher speeds,
Right.
and you've got the rear motor going when you don't really need to have it going. When you're just, let's say, cruising on the highway, when the front drive unit is completely sufficient for providing the power to keep the vehicle at constant speed. That's when it naturally wants to disconnect. But in sport, it stays connected, and it depends on the drive cycle, but call it 5-ish%.
I'll take 5% any old time. That takes quite a bit of weight to get to that.
Yeah, that is exactly right. And that's the reason for that whole disconnect strategy, and it gives us the benefit of on the highway effectively having the range that you'd have with a smaller performance single motor setup. But then the moment you hit the throttle, you get the dual. You get both motors. It's, as you know, very, very quick.
Yeah, it's plenty fast. There's no question about it. Like I say, I didn't get a chance to take it off road.
That'll be a video I'd love to see.
But,
I love
I don't think you want to see that. That would be bad. We'll save that one. And besides that, I don't want to buy a broken one. I don't think your guys got any sense of humor here in Detroit. But at the end of the day, I think that a lot of people buy brand X Jeeps. I never did. When I could afford it, I started buying Rubicons, and that's what I kind of look at is the quad is a Rubicon, and the other one is for going to the grocery store. But I still think, based on what I drove and whatnot, it's not just a Rivian with two motors. It seems to me to be a pretty good vehicle. Now, your guys did suggest that I can borrow one for a while. My wife was on that like white on rice, so I'm pretty sure that we're going to take them up on it and take a look. Okay. And you know what? There's something I forgot to do at the beginning of this. All you financial analysts and whatnot, no, I do not have any Rivian stock. No, I am not getting paid for this. It's just so stupid lately. But anyway, no, all the guys that have got a chance to fool around with it were pretty impressed with almost everything. I mean, we'll find fault with pretty much anything, but we were very impressed with what you've done. I think this is a great step. I love the fact that I'm a big fan of EVs. That is no denying. I think you guys have done a good job, and I really think that this is going to. Oh, wait a minute! I forgot the big question. How much cheaper is this than the quad?
It's a lot cheaper.
Good God, that was supposed to be question number one.
That's the whole point, right? Yeah. We've talked about this even in some of our earnings calls. This drive unit is a meaningful cost down. Both because we no longer have a rotor stator that's coming from a third party that has a lot of margin built into it, but also because it's all integrated as one unit. So the idea of like a 3-in-1 assembly with vertical axis, layering, as you talked about. If you were to look at the two different lines, we've got all things that would be sending all kinds of red on your product development sort of process because you have different axes for assembly.
Right.
Whereas on this, it's all vertical, all designed around vertical from the get-go. So I mean, it's significant double-digit cost savings. Significant.
Wait a minute. Have you turned into a politician? What can you throw a number at me so I can?
Double-digit could be somewhere between 10 and 99. So
10 and 99. Okay, good. Well, that's double-digit. Okay, good.
Yeah, no. I mean, we've talked about this whole system being greater than 25% reduction in cost.
Oh, from the quad to the dual.
Yeah.
Okay, for the motors. For a second there, I thought, wow, I'm trading mine in right now.
Yeah.
Yeah.
For the drive units, right, on a motor basis. Yeah.
Yeah. Okay.
But which is significant, especially if you have
It
two
is.
motors or four motors. Yeah.
Look, anything, as far as I'm concerned, anything that's going to get the cost down is going to be the right thing to do. I think you guys did a good job, a really good job. I mean, we're paid to nitpick, but I will tell you, this was a very good effort. Your team should be commended. They did a great job. Yeah.
Well, thanks, Cindy. Yeah, and the areas that I'm sure you've noticed, and we've talked a bit about here, around the power module, around the bus bar, we know about those, and we're working on them. But we'll look forward to seeing the video of your teardown.
Okay, good. All right. Well, we'll work on that then shortly. But this will keep everybody on pins and needles, right? So
Exactly.
Okay, good.
All right. Great. Thanks, Cindy.
Well, thank you, RJ. Thank you. Have a great day.
You too.